Welcome to a lesson that will show how to round 7,345,862 to various place values using both the number line as well as the formal rules for rounding outlined below. In our first example, we're asked to round 7,345,862 to the nearest million. So to round this using the number line, if we were to count by millions, notice how the given number would be between 7 million and 8 million, where in the middle we would have 7,500,000. And now let's go ahead and plot 7,345,862 on this number line. Well, we know it's less than 7,500,000, so let's just say it's approximately here. To round this number to the nearest million, we need to determine whether this number is closer to 7 million or closer to 8 million. And notice how because the given number is closer to 7 million, the given number rounds down to 7 million when rounding to the millions place value. The method of rounding using the number line always works, but there is one special case. If the given number happens to be right in the middle between the two possible rounding values, the rule is we always round up. Now let's round the given number to the nearest million using the formal rules for rounding. Step 1, we find the digit in the rounding place value. Because we're rounding to the nearest million, notice how the 7 is in the millions place value. Step 2, we look at the digit to the right of the rounding place value, which in this case is the 3 in the hundred thousands place value. So the 3 is our decision maker. It tells us to round up or down. So because we have a 3, and a 3 is less than 5, we round down. To round down, the digit in the rounding place value stays the same. All digits to the right become 0. Because we're rounding down, the 7 in the millions place value stays 7, and all digits to the right become 0, giving us 7 million. If the 3 happened to be 5 or more, we would round up, which means the digit in the rounding place value increases by 1, and all digits to the right become 0. Let's look at our next example. We have the same number, but now we're rounding to the nearest 10,000. So using the number line, if we were to count by 10,000s, notice how 7,345,862 would be between 7,340,000 and 7,350,000. And again, it's helpful to find the value in the middle, which in this case would be 7,345,000. So notice how the given number is larger than 7,345,000. So let's say it's approximately here. So because the given number is closer to 7,350,000 than it is to 7,340,000, the given number rounds up to 7,350,000. Using our formal rules, step 1, we find the digit in the rounding place value, which in this case would be the 4 in the 10,000s place value. Step 2, we look at the digit to the right of the rounding place value, which in this case is the 5 in the 1,000s place value. And because we have a 5 here, and 5 is 5 or more, we round up. The digit in the rounding place value increases by 1, which means we increase the 4 in the 10,000s place value to a 5, and all digits to the right become 0. So we have 0, 0, 0, 0, which does give us 7,350,000. Let's look at least one more example. We're asked to round the same number to the nearest 100,000 this time. So using the number line, if we were to count by 100,000s, 7,345,862 would fall between 7,300,000 and 7,400,000, where once again in the middle, we'd have 7,350,000. So plotting this number on the number line, it's less than this middle value. Let's just say it's approximately here. So because it's to the left of the number in the middle, we can easily see that the given number is closer to 7,300,000 than it is to 7,400,000. And therefore the given number rounds down to 7,300,000 when rounding to the nearest 100,000. Using our formal rules one last time, we begin by locating the digit in the rounding place value, which in this case is the 3 in the 100,000ths place value. Now we look at the digit on the right, which is the 4 in the 10,000ths place value. So the 4 is our decision maker. Because 4 is less than 5, we round down, which means the digit in the rounding place value stays the same. So if the 3 stays the same, all digits to the right become 0, giving us 7,300,000. So it's important to notice when rounding down, we do not change the digit in the rounding place value, but when rounding up, we do increase it by 1. I hope you found this helpful.